Hi, this is Team Jabroni. We're doing the steganography project. I'm Christian. I'll be going over the recovery methods.
I'm Alex, and I'll be going over the embedding process.
I'm Sally. I'll be going over the GUI.
So first, I'm going to go over the first few custom functions. The flatten function is what it's called. For the first line, it computes the threshold between black and white pixels, and then we use that threshold in order to convert the intensity image to a binary image of zeros and ones. And then the next one is our expansion function, where it just concatenates the image along three arrays. This is used for the recovery process, covered later. And then for our next custom function would be the first embedding process. This one is specifically for the red channel. So first we got the red channel of the selected hidden image, and then we flattened it and we took the size. That's for the looping process. So first we run through and it analyzes each pixel, and if it comes through a pixel of the hidden image and it's white, then it will go to the next line where it would divide the red channel by 2, and if the corresponding pixel in the original image is even, then it'll add 1 to that red channel. On the other hand, if if the loop goes through and it finds a 1, which is a black pixel, it would go to the corresponding red channel, and if that corresponding pixel is odd, then it'll subtract 1. And then for the ending, we just replace the original red layer with the new red layer in order to embed that into the dog image. Our next embedding function is the add red. The first few steps are the same, and then for this one, when the loop comes across the white pixel, a 0, it will just add 5 to the corresponding red channel, and the ending process is the same. For our subtract red, it's the same in the beginning, and for this one, when it comes across a black pixel inside the hidden image, it will subtract 10. And then for our division embedding process, it would when we run across a white pixel, it would go to the corresponding pixel inside the red channel, and it would divide it by 4. And if there is no remainder in the pixel after it's divided by 4, then it'll add 1 to make it a non-zero number. And on the other hand, if we come across a black pixel, then it would go to the corresponding pixel in the original image, and if the rem function finds that it does has a remainder, then it would subtract 1 to make the pixel number 0, or it will subtract the 2 or 3 to make it 0 no matter what. And that's it for the embedding functions. Now we'll go to the recovery.
Okay, so we'll start with the odd-even recovery method. So for all of these recovery methods, we'll be starting off by making an empty matrix with zeros, 400 by 400. And then we'll also we'll use the numL function to find the number of elements within the red dog image. And then so here for odd even, we'll use the mod function to to check if the pixel value is even. If it is, then in the empty matrix, the corresponding pixel will display as 0 or white. and if it's not, then it'll be assigned 1, which would make it black. And then after this, we'll use our expand function for the hidden image in order to display the recovered image. And we'll do this at the end of every recovery method. So then moving on to the add function recovery method, what we'll do is we'll compare the red dog image with the original image, and if the new one is a pixel value is greater than the original, then we'll set it the corresponding pixel equal to 0, which will make it white. And if it's not bigger, then we'll set it to 1, which will make it black. And then again, we'll use our expand function. And then for subtract method, it's pretty similar, only we'll check if the original image pixel value is greater than the new red dog image. If it is the case, then we'll set the pixel value equal to 1, which will make it black. And if it's not greater than the new one, then we'll set it equal to 0, which will make it white. And then finally, we'll move on to the division recovery method. So for this one, we'll use the rem function, which will check, or which will divide it by 4 here, and check what the remainder is. And if the remainder is non-zero, then the corresponding pixel will be set to white, which is at 0. And if it is 0, then we'll set it to 1, which will make it black. And then as a note, all of these recovery methods are for the red channel, and it'll be the same for the green and blue channels. You'll just switch this number here to 2 or 3. And then we'll move on to the actual GUI here.
Okay, right now I'm gonna run the GUI for our program. First, we load the normal image, which is the dog image. For our program, we can select up to 3 hidden images to embed into our normal image in different channels, which is red and blue and green. So this one I will use odd and even red method to embed. This is the next hidden image. I'm gonna use division by 4 in the green channel. For the last hidden image, I'm gonna use subtraction in the blue channel. Then I'm gonna save the image as 1, 2, 3, 4. Then we're gonna load the embedded image 1, 2, 3, 4. Just make sure for recovery we pick the method that go along with the embedding method. So the first one is odd and even. The second one is division by 4 in green channel. And the third one is subtraction in blue channel, which it works. And we also built in a reset button to clear out the graph in our GUI. That's it.